Hi, I'm Antoine Mautier, OW2 CTO, and thanks for joining me today for this session about dependency management. In this talk, I will try to overview how, with Fasten project, we are trying to improve dependency management. We'll see how it can bring more accurate results by introducing call graph into dependency management resolution. But first, I will take a step back and try to highlight pros and cons of reusing dependency and highlight some great tools available to help us doing a better job regarding dependency management. So as I just said, if you are creating a new software, it's very unlikely you start from scratch. You're probably always reusing some existing dependencies. You at least using the feature of your operating system, but more than that, you're using your programming language standard library features, and you're using probably several third-party libraries. Those libraries are really the building block of your application, and when you putting them together, you need to be careful because those dependencies can bring various benefits, but also can bring some drawbacks to your overall application. But first, let's have a quick look at different kind of dependency you may have in your project. You have here, for example, two types of dependency, two different categories of dependencies. You have the direct dependencies of your project. This is really the dependency you declare in your project and the dependency you need. You decide to include these dependencies. But those dependencies might have themselves, again, dependencies, what we call transitive dependencies. Those are the dependencies of your dependencies, and this can go on and on. And at the same time, a direct dependency can be also a transitive dependency. This is what you can see in my example here. It's a case for the dependency Z that is at both time a direct and a transitive dependencies. So this build up a kind of graph of dependency. And here it's quite simple, but you have to add that the version of your dependency. And it can bring also conflict related to the version, because you might want the version 1.0 and one of your dependency might require the version 2.0 of the same dependency. So this is a kind of complex problem to deal with. And this problem becomes bigger due to the number of dependencies we include. We include more and more dependencies, and all those dependencies, you'll need to manage them. I mean, when you build your software, you need to download them, make sure you have the proper version, you include the transitive dependency, resolve potential conflict related to the version, and this at large scale. So to solve such problem, thankfully, we have for quite a long time several tools that can help us. Those tools are, for example, in the Java ecosystem, Maven, for example. Maven can greatly help you as it will take care of downloading all the dependencies, solving the conflict. You have also still for Java ecosystem, Gradle that do the same kind of job. And every language has its own tools to deal with such problem. For example, for Python, you have pip tool that will rely on central repository to get the dependency, and so on. Here, I'm only illustrating 3 different programming language because those are the one that the Fasten project I will present later on focus on. But of course, you have the same for JavaScript or for Go ecosystem. You find this kind of tool for all programming language. As I said, reusing dependency brings some benefits, but it will also bring some risk. For example, if you have a dependency either direct or transitive that have a security issue, this security issue will actually might propagate up to your software. impacting your users. For example, if you remember, the Equifax data leak was related to a dependency. Actually, it was struts that was not updated for like two months, and so leads to this data leak. So it's really important to take care of your dependency. It's kind of magic when you use a build tool. It downloads the dependency, it put everything together, but it's still, you still need to get to give some attention to your dependency. Another kind of issue you might have with dependencies is if the dependency is removed from the central repository. For example, such situation arises with npm when the left pad dependency was removed from the public repository, leading to several software not being able to be built anymore. And another challenge when reusing dependencies is that you might face some licensing compliance issues, especially as most of the publicly available dependencies are open source. You need to be careful about the compliance of the library you are reusing with your own software license. And it can become complex when you have a very large network of dependency you don't fully control because of the transitive dependency. So here I highlight a few of the potential issue, and now I want to try to give you a little bit of hope and highlight some solution and share some recommendation. The first one is probably how you choose dependencies. And here, sadly, I don't have a magic solution. The only recommendation I can share maybe is pick the popular dependencies. I mean, you cannot really go wrong with one of the top popular Java library, for example. If you're using the Spring framework, it's quite popular, you know, it's well maintained. There is regular updates to fix vulnerabilities. So yeah, I think the first step to correctly manage dependencies is by carefully choosing them before adding them to your project. Also, one of the steps is to remove the dependency you don't use, because they make your project bigger, they can bring some security issue, so you just want to remove them if they are not needed. And to do that, we have tools such as the one I'm illustrating here. It's called depclean. It's a Maven plugin. Here I'm focusing on Java, but of course, such tool exists for various programming language. It's just, I know the most Java, so I'm giving the example based on this language. So depclean will help you get rid of all the dependency you don't need. In this example, I include SLF4J dependency in my project. And here you can see in this example that I'm calling SLF4J, I'm logging a message. And you see in the output of depclean that it reports that this dependency was actually used as a direct dependencies. Now, let's see a variation of this code where I use Java reflection to actually call the same method. I try to log a message, but I'm using reflection. And here we'll see that depclean is not able to pick up this because it does static code analysis, and reflection is a dynamic feature of Java. And so depclean is not able to identify such a code. So this is a limitation of such tools that you need to be aware of. There is a lot of tools that are out there to help you, but you need to know their limitation. But still, depclean is a great tool to do a little bit of cleanup in your project to minimize the set of dependency. Also related to security, you probably want to monitor a little bit the such websites here like NVD, for example, or GitHub Security Advisory to get the information when one of your dependency is actually at risk, when it's include a security vulnerability, so that you know that you need to upgrade. But monitoring those websites is not really the way to go, because you won't go daily to check those websites for each of your dependency. You need to automate that. And in order to automate that, you have some tools again. We have here an example with Dependabot. It's probably the most popular one because it's part of GitHub. It's integrated in GitHub. And again, here I have a quick example to demonstrate some limitation. Here in my example, I have a dependency on gRPC neti artifact. And this artifact has a transient dependency on neti codec HTTP2. And actually, this transient dependency, this transitive dependency, have a security vulnerability in the version I am using in this example. So what I need is I need to apply some updates. But here in this example, you can see on the screenshot that Dependabot is not able to identify this vulnerability. It's because it's a vulnerability on transitive dependency, and at least for Java using Maven, Dependabot is not able to identify this. So we have some limitation here of the tool. Again, another tool that can help us is Snyk. This tool is actually able to overcome the limitation of Dependabot by looking at transitive dependency. But again, here I have an example with, it's not really a limitation, but at least a drawback, yeah, something that can be better with Snyk. In this example, I'm including Commons IO 2.6, version 2.6 library. And again, it has a non-security vulnerability. And actually, my code doesn't do anything. It's just an empty void main function. So I don't expect to have any request, any feedback from the tools asking me to update. I would rather expect a notification that I have an unused library and I should remove it. And actually, Snyk tell me that I need to update and propose a pull request to update to version 2.7. So it's because it's not able to identify that I'm not using the library. Actually, also the same kind of limitation exists when working with Dependabot. And also if you are using the Maven dependency check plugin, you will face same kind of limitation. They will ask you to update, whereas you should rather remove the library. Here I take an example where I don't call at all the library, but I might call also a subpart of the library that is not concerned by the security vulnerability. This is pretty much the same scenario. So overall, the tools I presented so far lack some accuracy. And this is what Fasten project try to overcome. The tool I presented so far work at the package level, at the library level. They work with this graph of dependencies. And here with Fasten, what we want to do is work at the function call level, at the method call level. We actually build a call graph of the application and all its dependencies and enrich the code graph with some extra information like what are the non-vulnerability, but we put this information at the function level. So it's allows us to be more accurate when we report that your code is impacted or not by a security vulnerability. So here is a little bit more information about how it works. Actually, in order to be efficient, the Fasten project will go through all the available public library, public artifact available in central repository. So for example, it will go over all available dependency in Maven Central and analyze them. By that, I mean it will generate the call graph for each individual library and store it in a central fasten repository. It will also analyze the information coming from various other sources, such as the CV, the license information, some code quality metrics, and it will enrich the call graph with all those metadata. This approach allows us to have a kind of cache, a kind of pool of information regarding all the most common library you are likely to use in your project. So this way, when Fasten processes your project, it will not need to generate a call graph and gather information about each individual dependency, because they are likely to be already there in the central Fasten repository. Actually, if we took a closer look at how it works when Fasten is executed, it will go something like that. So you have your Java project, let's say, and with that is configured to be built with Maven. So when you run the build, first step is like Maven will download all the dependencies from Maven Central, store them locally, and compile your code, build your code. And then here, Fasten step in. Fasten will build the call graph of your application and only your application. So you will have this call graph and know exactly what method calls happen in your application and what calls are going outside of your application to third-party library. For all your dependency, Fasten will get the information from the central repository. So it will download the call graph. It will download the metadata from the central repository. If the dependencies are not available in the central repository, it can actually build the call graph locally. And once you got all the call graph, so for your application and all the dependency, it will do what we call stitching. It will stitch together all the call graph to have this global call graph. And so you have a full call graph of your whole application. And it will have also all the metadata on this call graph. And Fasten will be able to look at the path in this call graph to be able to identify if you find a path between your application code and, for example, a vulnerable function in one of the dependency. And only if you find such path, it might report you that you need to upgrade to the newer version of the library. If such path doesn't exist, it will not ask you to do any updates. So it will prevent you from having this, I can say it's kind of noise that some toolings reports when they ask you to update, whereas you don't use actually the code that is problematic, and that includes the vulnerability, the security issue. So here, Fasten will be able to be more accurate. So again, what Fasten does is like, it will generate the call graph for your application, get the call graph for your dependency and all the associated quality, metadata, security vulnerability, license, and so on from the central repository, and stitch that all together in order to be able to report an accurate, give you an accurate vision of what action you need to take to fix potential issue on your project. So that's the introduction. I'm quite short on the time here, so that was quite fast, but that's the introduction on the how Fasten project works and what it can deliver. This project is actually an open source project. I should have probably started with that. It's developed by a consortium, a group of different companies, also involving some universities and some nonprofit organizations that all collaborate on this project, but it's open to contribution. So if you are willing to give it a try, share your feedback, ideas, and so on, don't hesitate to join us. You have here the GitHub repository URL. And if you want to give it a try, I recommend to start probably with the Maven plugin. You can try to run it locally, and don't hesitate to share your feedback regarding the fasten project. And now I think I'm done. So I thank you all for your attention, and I will take a question if you have any. Thank you. Okay, so I will answer the first question about how fasten identify the classes used. Is it parsing the source code? Is it parsing the binary code? How it works? Actually, fasten will rely on a third-party library. It's called the Opal project, and it does static analysis, so it will work on the bytecode for Java. So it will work with a Java bytecode to identify the various method call and to build the code graph. So it doesn't need to check out the source of the project to identify which function is actually called. Next question is about the integration in the Eclipse IDE, and if we have some visual tool to help understanding the code graph and having a view on the code graph. Currently, such tool doesn't exist. We don't have integration with the Eclipse framework, Eclipse IDE, but we provide a description of the code graph format. It's actually provided as a JSON output, and so I guess you can build your own visualization tool on top of Eclipse IDE features. We are working on some visualization tooling, but they are still under development. Another question is about where can we run fasten, how we execute fasten, and can it work locally without requiring access to the central Maven, central fasten repository. And actually, yes, it can run locally. It can build a call graph for your application and the dependency of your application by running all locally without any external call to the fasten central server. Also, as it's all open source, if you're interested, you can deploy the server internally and use your own fasten server. It's kind of heavy on resources because you need to crawl public repository like Maven Central or PyPy. So we recommend to benefit from the work already done by Fasten Central Server. It's improved the performance, but if you want, you can be totally isolated from the infrastructure we provide. So a question regarding also how Fasten deal with indirect dependency that are injected with inversion of control. And for such a situation, what Maven Fasten try to do, it will actually improve the call graph built using the static analysis with some dynamic generated call graph. So you try to run the code, and that should help to enrich the call graph. But this is kind of the theory, because to be able to execute the code, we need to be able to have an environment that allow us to do so. And this is quite challenging. First of all, we need to identify where to start in the program execution. We usually can use, for example, a main function if it exists, but also we can rely on unit tests. But the tests are not a good source here, because usually they have some stubs, so we don't really execute the whole software. So it's still something we are investing. We are looking for some solution and improvement regarding all these aspects, especially like feature like reflection and things like that, that are mostly dynamic and happen at runtime. And here we try to find some solution to build accurate code graph, because it's really have an impact on the accuracy of the fasten results. And I think, let me double check. I think I answer most of the question we received so far. Yeah, what I want to highlight, maybe a few comments, because I was rather quick in the presentation about that, is really the challenge in the project is to be able to build accurate code graph due to this feature I was mentioning earlier about dynamic execution at runtime, like the reflection in Java, and you have similar feature, for example, in Python. So we try to combine different approach to build the code graph, and also to build this efficiently. I got a few more questions. So regarding the implementation of the central server, I'm asked, how is it implemented? Is it a set of files on a central HTTP server? Actually, it's a combination of different technical solution. First off, for the graph data, we use RockDB to store them, to make sure we have good performance, because it can be a really large graph, as you can imagine, trying to store all the calls that happen in quite large libraries. We have a PostgreSQL database to store metadata associated with the code graph, for example, the non-vulnerability, license information, and so on. And we also do some storage. For example, when we download the binaries from central repositories, we store them locally. And so on top of that, we have REST APIs that allow the Maven plugin or Python plugin and so on to access the data and get the data from the central server when they process the code graph for an application developed locally on the computer of the developer or on a continuous integration server. And also, it's possible to, as I said, run your own fasten server, and you can point it to your own Maven repository, for example, and it can scan your company repository and analyze the repository to provide rapid results when you are using your own in-house developed libraries. Regarding the dependency check plugin, and is there an existing replacement that used the fasten service to perform similar operation? Actually, part of the project, the fasten project, as part of it, we are developing a Maven plugin. So yes, but it's not yet a full replacement of dependency check plugin. And I think it's more something that you will add as an extra to the dependency check plugin. I think it's not really designed to be a replacement. And I think now we reached the end of the session. Thank you all for watching the talk. I know that we have a few issues with the recording. Hope you still enjoy it. And thank you for all your questions, and enjoy the rest of the conference. Thank you. Bye-bye.